Hello and welcome to this video. My name is Matthew, and in this video I'm going to demonstrate how to conduct PIAAC analysis using the public use file. And in this case, we'll be conducting multiple regression-based analysis where the plausible values are set as an independent variable in the model. You can see here the link to the Google Doc where we make a rationale for this script. Here is the link here. It's open to everybody. In this rationale, my colleague and I, Kai Da, provide an explanation about the mathematics and why this analysis is necessary for PIAAC data. We provide all the equations and all of the references necessary. For this specific example, we're going to focus on low and moderately qualified adult individuals from Kazakhstan and looking at predicting the extent of adult habitual reading at home based on the predictors of literacy, which are the plausible values, highest qualification, gender, age, and native tongue. This code is flexible such that other models may be integrated into the lapply function, enabling the repeated analysis necessary. For example, one might want to predict low versus high levels of education as a dependent variable, in this case, a binary outcome. For this, you could run another model just by changing A, the main model, and B, the main model family, for example, logit or probit. When you're working with R, it's really important to carefully manage and prepare your files and your data. So first, you need to obtain these documents from the internet. First is the codebook. You also need your data of choice. You can get your country data from in terms of CSV files, or you can get your country data in terms of SPSS.sav file. In this video, we are choosing the SAV file as R can manage SPSS type data. What you'll need to do is create a folder on your desktop and make a link between R and that folder. To do this, we first need to set the working directory. If you have a Mac, you can follow such code like this, or you can just do it manually, which involves going to Session, Set Working Directory, and Choose Directory. This will set your working directory down here. Once you've linked your working directory with this session here, or this tab, or R script, then you can begin your coding session. Of course, we should clear the global environment first to ensure that there's nothing affecting our analysis in our global environment. We can press Run, or we can press Command Return on a Mac, or Control Enter on a PC. Next, we can install a package that manages packages. This package is called the Pacman package. Just highlight and run. This will install the package if you need it. Now that you've got the Pacman package, you can use the Pacman package's pload function and install and load to the library those packages as necessary. You can check the directory, i.e. what folders are in the folder, or the working directory, I should say. And you can see I've got multiple files there, but we only need one because today we're only looking at Kazakhstan. We use the foreign packages read SPSS function to download, to read in the SPSS file into R. This shouldn't take too long and it should populate in the global environment. You can see the dimensions. We have 6,050 observations and 1,328 variables. Let's look at the variables themselves. I like to use the summary, structure, and psych-describe functions. Let's explore the plausible values. We can see that it's a number. That's fine, and we can see some of the descriptives here. We want to deal with numbers when we're doing analysis like regression. This is the best and safest way. Let's look at this qualification level of each person. We can see that it's a factor with 15 levels, but remember we only want the low and moderate levels of educated persons for this analysis. Let's change this a little later. Gender, we can explore gender with the levels function because it's actually a factor here. And we can recode it as a numeric, and we can see that there are two levels. Female is 2, male is 1. That's how we're going to code it later. The age variable, explore that. Again, there's different groups. We can run that and explore that variable, make sure there's no problems. Now, the next variable is called native language, but it's actually whether or not the native language of the person was the same as the language of the test. It's a binary variable with 2 or 1. But let's recode that to 1 or 0. Now here we have the actual dependent variable in the regression model. Let's recode that as a numeric. Now remember, PIAAC uses a multi-stage clustered design. In this case, we have to adjust the standard errors of the coefficients in the regression-based model based on this multi-stage clustered design, and also the fact that the person ability or adult literacy or numeracy is estimated using item response theory. So let's move on to exploring some of these weights. We have a full sample weight, and we have the replicate weights. We need to use all of these values here, both full sample weights and replicate weights, when we're adjusting the standard errors for the coefficients. There's also a sequence variable for each respondent, which is helpful. Let's move to data manipulation. Here we're using the dplyr packages select function to just take the sets of variables that we need. Now, remember, we're only interested in those adults in Kazakhstan with a low and moderate level of education as defined by the ISCED international standards. So we can subset the data based on people with those low and moderate levels of education only. Here we can do a recode so that they are either classified as low or moderate. Let's run this here. It uses the if-else function. We can see we've got 791 persons with low levels of education and 1,630 persons with moderate levels of education. Now, the read at home variable, the outcome variable, we're going to change this to a z-score. We're going to scale it and change it to a standardized score, you can say. We add that to the new data frame as a new variable. Let's use complete cases only. We just simply include the square brackets, a comma, and make use of this function for rows, because rows is before the commas, to subset only complete cases. You might want to use an imputation type approach to filling in missing data, but in this case, we're just only using complete cases. That is data points or persons with all variables in our model. We can check the predictors with the table and the summary functions. We can also check the predictors with the structure function before we run our models. So because item response theory is used, we have 10 plausible values for what might be possible in the population in terms of literacy. We can define a vector with each of those 10 plausible values, and we call this PV names. We use the lapply function and essentially loop these different names through this regression model here. So we're running the regression model 10 times with the same variables, and the weights we use each time is the baseline weight. This will give us 10 coefficients, 10 sets of coefficients. Let's run that. I'll move to the command return because it's easier. And we can extract the average coefficients using the apply function on the object and now analyzing columns and finding the mean. And you can see we've got the final reported coefficients that we're going to report in our final table. However, we need to make adjustments to the standard errors for those coefficients. So we need to account for both imputation or plausible value based variance or standard errors, and we need to account for variance or standard errors associated with the sampling approach for this research design. Again, similar to before, we're going to identify a vector of names, in this case for each of the replicate weights. Now, as I described before, there are different formulas to apply to these data, and these formulas are placed in the rationale here. We're going to implement equation 1 and equation 2 as functions. So we wrote these functions for you here. The first one is the function that is associated with equation 1. So we create that function, and you'll see the function populate up here in the global environment. Let's also create the function for equation 2. In this case, it's for sampling variance. And you'll see that equation populate up here too. Those functions essentially form the right part of the equations. Okay, so now our analysis is split into 10 different steps. Each step is associated with a specific plausible value. In this case, we run the model for plausible value 1. You can see here, it's all set up, plausible value 1 here. This is an independent variable in the model, as you can see, because the outcome is this variable here. Okay, let's run the model. Let's manage those outputs. And we're going to use these here later below in the text to come up with the final estimates based on the formula. Now, using this analysis for PIAAC means that you need to make adjustments for the coefficients, first and foremost. You then need to make adjustments for the standard errors based on sampling and imputation variance. You also need to make adjustments for the degrees of freedom in the model as well, based on the mathematicians named Welch, Satterthwaite, and also Rust as well. So here, I create a function for the Welch, Satterthwaite adjustments to the degrees of freedom in the model. I apply the function here on line 271, and I get a final outcome for plausible value 1 for the slightly adjusted degrees of freedom. We do the same for plausible value 2, and so on. Just bear with me. My computer is a little bit laggy. That's why I'm not doing all of it together. But it's probably best to just show you step by step. Okay, so we're up to plausible value 7. As you can see, each time adjustments are made. You can see PV7 here, PV7, PV7, PV lit 7 here, PV set 7, and so forth. Number 9. And number 10. So here we're applying the final part of the formula here for the variance due to imputations or plausible values. And if we print this, we get our variance components or standard error-based components for each coefficient attributable to imputations or plausible values. Next, we work out the variance due to sampling, which is here, basically, this part of the formula. We can see these variance components here. We add the variance components together for each element in the vector, and then we find the square root to, of course, get to our standard error. So these are the adjusted standard errors for each coefficient in the model. And it's very simple. We just simply divide each coefficient by each respective standard error to get the t-value. Here are the t-values here. You'll need to report all of this in the tables. Coefficients, adjusted standard errors, t-values, and also degrees of freedom. So let's find the adjusted degrees of freedom based on Welch-Satterthwaite adjustments. These are the degrees of freedom for each coefficient in the model. There's a final adjustment beyond the Welch-Satterthwaite adjustment based on Johnson-Rust. So let's just create that function and apply that function to that vector. So this is these are our final adjusted degrees of freedom for each coefficient in the model. With our t-value and degrees of freedom, we can now calculate the p-value. So we're just using this stats package. It's actually a base package, and the pt function, and the basic rule for estimating the p-values. So this is a function here. And we can apply that function to generate all of the p-values to be reported in the table. For these lines here, 475 to 478, we're simply collating all of the results of the analysis and reporting it in a type of table form. So here is your output that you can report in your table. Cool. And I just can make some notes here. I just made some notes here. So your table might read predictors of extent of reading at home. We can see that there are several predictors in the model. It appears that having a moderate level of qualification is an important predictor. Positive, it has a positive effect. Whether or not the test was completed in the person's native language made no difference. You can see there's no significance here and a very small standardized coefficient. Here, age. The older you get, the less you read, it appears, and this effect is highly statistically significant. Gender, being female, is associated with reading more. So you guys in Kazakhstan need to up your game. In terms of literacy, this is based on the PIAAC test distributed to adults for their literacy. We can see that there's also a small effect. It's actually not small because literacy is has a large standard deviation and so forth, but it is a significant effect here. You might like to standardize all variables in the model and run it again in order to make a fair comparison between coefficients. All right, so thank you for your time. Thanks to my dear colleague Kaidar for helping me with this code and working together to build this explanation for you. If you have any questions, you can post those in the comments below. Thank you so much for your time and all the best with analyzing PIAAC data. Thank you.